There's a machine orbiting above us, the size of a football field, moving at over 28,000 kilometers per hour, and can be mistaken for a star at night. It's one of the most complex structures humanity has ever completed. More than just a structure, it posed the question: amidst the tension down here, could it cooperate up there? The answer will take years, billions of dollars, and the cooperation of rivals once locked in a Cold War. But what they created is nothing short of historic. One of our most basic needs as humans is shelter. It's the first thing we look for when we move somewhere new. But at some point in our history, we stopped just looking around and started looking up. While ancient civilizations had some literature suggesting extraterrestrial bodies and habitation, the astronomer Johannes Kepler is credited as one of the first to write about living and traveling in space. Centuries later, other thinkers expanded on these dreams, proposing how people might one day travel beyond the Earth. But most ideas lack the engineering detail to make them real. That changed in 1928 when Austrian engineer Hermann Nordung published the first detailed plans for a space station. He envisioned a giant spinning wheel designed to create artificial gravity through rotation. He proposed building it on Earth, testing it, and then launching it in parts for assembly in orbit, an idea that would prove effective in decades to come. By the 1950s, space travel had become more than a dream. It was a frontier.
Russia had blasted a man-made moon into outer space. On every continent and in every land, the story of Sputnik 1 dominated the front pages.
The United States started designing orbital outposts, and one of the earliest plans was Project Horizon's modular space station, meant to house crews and support missions to the moon. This eventually led to Skylab, America's first real space station, launched in 1973. Meanwhile, the Soviet Union had its own ambitions. They imagined a massive station launched by the N-1 super rocket, but after a series of failed tests in 1969, they pivoted. Instead of one big station, they planned for smaller, more manageable ones. And in 1971, Salyut 1 became the first space station in history. The fierce rivalry between the US and the Soviet Union gave way, though briefly, to cooperation. In 1975, the Apollo-Soyuz test project marked the symbolic end of the space race. There was hope for future collaboration, but Cold War tensions soon returned, delaying those dreams. In 1984, President Ronald Reagan approved a new American space station, Freedom.
We can reach for greatness again. We can follow our dreams to distant stars, living and working in space for peaceful economic and scientific gain. Tonight, I am directing NASA to develop a permanently manned space station and to do it within a decade.
It wouldn't be a solo effort. NASA invited Europe, Canada, and Japan to join in its design and development. Modules were planned, contracts signed, and construction was set to begin. But by the early 90s, the cost of the project was climbing fast. Across the ocean, the Soviet Union had its own plans, Mir 2. Construction began in the 80s, but after the Soviet Union collapsed in 1991, so did its funding. The project was downscaled and on the verge of being abandoned. With both Freedom and Mir 2 struggling, the US and Russia made a bold decision to merge their plans, and in 1993, they announced the birth of a new project, the International Space Station, the largest and most collaborative space endeavor in history. Assembly began on November 20, 1998, with the launch of Zarya, a Russian module. 2 weeks later, the American Unity module followed. Docked in orbit, these two modules, once separated by Cold War rivalry, now formed the heart of a united effort, yet they were uninhabitable. That changed in July 2000 when Zvezda brought life support systems and living quarters. By November, the first crew arrived. The ISS had become a home. Over the next decade, the ISS expanded piece by piece, with each module connected in orbit, and by 2011, its core construction was complete, yet it continues to grow. Today, the ISS orbits Earth at about 28,000 kilometers per hour. It completes a revolution around the Earth every 90 minutes approximately, completing about 16 revolutions in one day at an altitude ranging from 370 to 460 kilometers. It weighs roughly 420 metric tons, a pressurized volume of about 1,005 meters cubed, of which 388 is habitable. The solar arrays generate 75 to 90 kilowatts of power. Debates exist about the actual cost of the ISS, but the range of 100 to 150 billion has been widely accepted, making it the most expensive object ever built. 288 people from 26 countries have visited. The ISS was built to last 15 years, but it's now been over 25. Some components are aging, others are nearing failure. In 2031, the ISS is scheduled for retirement. NASA plans to deorbit it, crashing it safely into the South Pacific Ocean, into a remote area known as the Spacecraft Cemetery. The International Space Station is not just a lab, it's a monument, orbiting proof that in the vast silence of space, humanity found a common voice.